BOOL.
Okay, so I've got a script loaded up here in Visual Studio, and I'm just going to walk through the different elements of it, what they mean, and then we'll show an example in Unity of these things in motion. Again, I don't want to do a tutorial of how to make a thing move or change color or whatever. All I want to do with these videos is kind of break down the things that you see in a script, what they mean, how they're used. And remember, I'm not any kind of professional. I've just been learning for 6 months. I just want to try to make some of these concepts a little bit easier to grasp, because some of them I think were a bit tricky for me, and you may be in the same boat. So that's what this is all about, right? Nothing that you'll see in these scripts that I provide are necessarily a great way to do them. They might be terrible ways to do things, but at the very least, if you can understand what is happening in them when you look at a good piece of code, you can go, oh, okay, I see what they're doing here. This is referencing this, etc. Right? Okay, so let's just get into it. First of all, you have the namespace being used. These are just naturally built into Unity scripts when you start a new one. You will occasionally add different namespaces, or you can make your own, but that's for another topic, another day. Moving down, we have our script name or class name. You have to make sure that the file name and the script name actually match, or you'll run into problems. Anyway, getting down to the variables. Up at the top here, we've got our game object named Victor. So at the top of the script, so we've got 3 fields here for our variables. First, we designate if it's a public or a private, and then what data type it is, and then the name of it. So we can define things as public or private. Public means that you can access that variable through the inspector, and it also allows other scripts to get references to it or modify it. So public can be dangerous if you're not careful, because you could have scripts changing other scripts. It won't just happen like randomly. You will have done something to do that, but just keep that in mind. So I actually don't need this to be public. We've already got a definition for Victor down in the script below, as you'll see as we move on. So next up we have rigid body 2D. I've just named it Victor underscore RB. So the rigid body 2D, you can read up on the different ins and outs of it, but essentially that's the physical aspect of the object. So that gives it mass, it gives it friction, it gives it its relationship to gravity, how much gravity affects it, things like that. Vector 2 and Vector 3 are both references to the object's position in physical world space along the 2 or 3 axes, so the X, Y, and Z. I'm Canadian, it's Z for me. Okay, so we've got a Vector 2 because this is just a 2D script that we're working on, and after that, again, we've got a public variable. This is a float. So a float is a number. It's like an integer, except that it has a decimal place. An integer is used more frequently, but there will be times where you need to use a float for that precision. There are also some components that require a float, which we'll get into. For now, though, we've got a public float of move speed 10 and F. Next up, sprite renderer, Victor Sprite. So as you can see, it all follows a pretty similar kind of format. We've got a type of data or a component, and then the name that you want to give to it. Just be careful about how you name things, because if they're too similar, you can kind of frustrate yourself by forgetting which one is which, or using the wrong one in the wrong place. After that, we've got our colors, Victor color, etc., etc. And let's get down to a couple more here. So BOOL, a BOOL is just a binary like on-off, right? It's a true-false statement. You can define it at the top. I think it naturally starts as a false value, but I'm setting it as true right at the gate. And then we have a string. String is a field containing letters and numbers with quotation marks around the inside and out. So our string is Victor says, Victor is my cat. Okay, so these are the variables of this script. Below that, where you see void, these are the functions. There's always a start and an update function when you create a script, but they don't necessarily need to be in a script. That's just kind of the automatic assumption. You can create your own, you can modify them. So start is called before the first frame update. So start happens before the update functions. When you load a scene, if the game object is present, if it is active and has a script, it will run the start function. So that's where you initialize your variables and you set up your references. So going back to the top, let's look at the relationship here. So we have our game object named Victor. In start, we are saying Victor is equal to this game object. So we've set a reference. Victor is this game object, right? Seems self-explanatory. Victor RB. So now we're saying that game object named Victor, we want to get the component of rigid body 2D, and that is what Victor RB means, okay? So again, we're establishing that there will be a rigid body named Victor RB, and then the start, we say what that is. This is called caching. So you want to try to cache things as much as possible, whenever possible. Instead of doing this, we could say, put that into update. This would be terrible because it's going to call for Victor RB every time update runs, which is every frame. So we don't want to do that. We'd want to do it just once and then it's set. I'm going to try to not do things like that where I say you should or shouldn't do this, but that's generally a good tip, is look out for caching and look out for references that are happening in update, because that will hurt your performance, and if you don't know what you're doing, well, I guess that's why you're watching this video. Right, so in the start, we're just establishing what these terms mean. We're saying red is a color with these values. What does all this mean? I'll provide links to the Unity scripting API, but generally what you want to do when you look at a tutorial or a piece of code is exactly that, right? If you don't know what color means and what these numbers mean, you can Google. You can go to the Unity script and say, Unity new color, and it will give you a definition for those things. Let's do that right now. So I've typed in scripting API color. It's a representation of red, green, blue, alpha colors. Right, so if we look back in my script, we have 1, 0, 0, 1. And if we look at our API, that means red is at full 1, green 0, blue 0, alpha, which is that last value, is 1, which is full. Okay, and there's also a handy reference here to see that. Those numbers are just floats that go from 0 to 1, so that could be 0 0.2, 0 0.5, 0 0.8, 5, 6, 7, 2, 9, whatever. Okay, and here's another example of something that we can highlight. So Victor color equals Victor sprite dot color. Now we've already said that Victor sprite relates to the sprite renderer of Victor, the game object. So you can see how it kind of flows. We start out with our game object. We get the sprite renderer from that game object. And now we're modifying the color of that sprite renderer. Components will have their own sort of subcomponents, if you want to call it that, their own variables that you can modify. Once again, using the Unity API scripting, what is it called? Once again, using the Unity scripting API, you can see what these different components have available, what things you can modify and use. So we're accessing the color property of the sprite renderer on Victor. Right, okay, so we've established all of our variables as much as we can. But what we haven't defined in the start function is our movement. So movement, again, is the position of an object in the world. So we're saying movement along the x-axis will be equal to the input that we give it on the horizontal axis. Same with the y component. And then down here we're saying the rigid body, so the physical aspect of our game object, Victor, is going to move position related to the movement that we give it, the movement speed that we give it, across time. Right? Time dot delta time is Unity's internal clock, for lack of a better phrasing. And we want this to happen over time. We don't want it to happen one frame, right? And if we look at the Unity scripting API on move position, so that would be rigid body move position. Okay, so that's a built-in function or accessible component of the rigid body. As it says on here, moves the kinematic rigid body towards position. Okay, so we're moving the physical component of Victor to its position plus the movement that we give it. So what does that mean? Okay. The input that we give it on the horizontal or vertical axis is going to be either 1, 0, -1, or anything in between. On the horizontal axis, a 1 would be all the way right, a -1 would be all the way left, anything in between would be a variation of that, right? Because this is happening over time, the position plus 1 will constantly change over time. So let's say the position on the x-axis right now for Victor is 5. And we tell it it's going to move to 5 plus the movement we give it, and let's say we're doing a full movement of 1. So we're going to now move from 5 to 5 plus 1, our movement is 6. But that 1 keeps occurring because we keep giving it that input, so it's going to keep moving. So now we have some if statements. So now we're checking if the input that we give it on the x-axis is greater than equal to 1, do some things. And remember, an input on the horizontal axis of 1 or approaching 1 would be moving to the right. So that means that if this object is moving to the right, we're going to change its color to green. We've already established that green is a color with these properties, and we've already established that the color we're modifying will be of Victor's sprite renderer, right? So Victor turns green. We're also flipping the sprite renderer. So that's something you can do to have an object's image flip. It's a built-in component or property of a sprite renderer. It's called flip X. You can do that with the Y as well. So we're going to say true because we want him to flip if he's facing that way. And then we're setting our bool is flipping true. Else if. So what that means is if this, we're doing this. Otherwise, if movement is equal to -1, do some other things. So in this case, we're going to turn him red. We are not going to flip the image anymore if it was, and is flipping will become false. The difference between these, you can see also, we have, in the first case, it's doing if it's greater than equal to 1, and in this case, we're doing is equal to -1. So if the input we gave it, say on a joystick or a gamepad, joystick, was not quite -1, it would not trigger this. But because I'm going to be using a keyboard, it will trigger, because using the keyboard input is always full on 1 -1. Little things can trip you up as well. So if we want to check if something is equal to something else, we use 2 equal signs. If we did that, we would be telling it that movement is equal to -1. We want to see if it is. So that's why you use 2 equal signs there. And if neither of these things are happening, we have else. Victor's color is just normal, is white. On a sprite renderer, if the color is full white, the image doesn't become white, it just is its full image self. Full image self, what the fuck does that mean? Okay, and then one more if statement. So we're checking if input any key down, we're going to do some things. So any key down checks the first time that key is pressed. If we did just input.any key, Update would function once per frame, and it would check if we had a key held down. Every frame it would do this function, which we don't want it to do. We just want it to happen once if we're pressing down on a key. So if we're pressing any key, we're going to execute the function cat_stats, and we're going to print to the console what Victor says. Victor says is the string here. Okay, so we have our string of Victor says. A string is just another data type that stores components similar to like an integer or a float, except this relates to characters, so you'd use it for like text, but you can also have numbers in there. In our if statement, that checks if any input happens on any key. We print cat_stats, and we also say, what does Victor say? Debug.log is just a way to print things to the console. It's great for checking if your code is actually functioning properly. And then lastly in the script, we have a function called cat_stats. So you can make a function any name you want. You close it with 2 brackets. So in our function cat_stats, we have 2 different ways to print to the console. You can either do debug.log, or you can just say print, and in either case you're going to have brackets and then quotation marks around any text you want to appear, plus sign, and then any variable you want it to print. So we're going to be checking that is flipping property, which as we know will be modified based on our movement. So if we are moving to the right and we execute cat_stats, it will say true. If we're moving to the left and running our function of cat_stats, it will say false. And then we're also going to print if Victor is wonderful, because he's awesome. So let's save that. Let's go into Unity. There's my guy. So this is our script. As you can see on the game object, I've already got the rigid body set up. We're not going to worry about going over any of the Unity stuff, but as you can see, I've got my public variable of move speed, which I can modify from the inspector, and because it's a float, it will allow that precision. That's too fast. That's perfect. That's how fast he moves. Okay, so let's hit play. So we move to the left, turns red, we're printing to our console. Is he flipping? Nope. Is he wonderful? Fuck yeah. And meow 420. And then we move to the right. Is he flipping? Yes, he is flipped. Meow 420. Great. So if we look at our sprite renderer, we can see that flip X property. If I unclick it, he goes back that way. And you can also, again, do that. So these are properties that you can modify through the script by using getComponent sprite renderer. Right, just like we've done here. Victor sprite refers to the sprite renderer. Victor sprite color equals whatever we tell it to be. Now I can modify his speed. That's much faster. So remember about the movement relating to the position of the object, right? So if we look at the X and the Y axis here, right now he's at 1 on the X scale. So anytime I give it that input, we're moving him to 1 plus the input that I give it. So that will be a number that is constantly changing based on the input we give it. And I think that's going to wrap it up for now. I'm not sure what else to go over in this video. If this was at all useful, let me know. If there are things that you saw that could be improved on or were just straight wrong, also let me know. But this is the kind of video that I want to do. It just goes over the very simple basics of how to use C# with Unity.